All right, so we're going to continue our look into adding and subtracting rational expressions. This is just going to be a continuation, provide you with a few more examples on how to do this. So in this first problem, we see that we got 1a plus 1a. Because the denominators are the same, we can just add the numerators. And we arrive at 2 over a. Notice that we add the numerators, the denominator just stays the same. Okay? Over here, we see an m plus 4 plus an m plus 4. Both the denominators are already the same. So we add the numerator. So an m plus a 4 turns into m plus 4 all over m plus 4. We see the same thing on the top and bottom. Anything divided by itself is just 1. Okay, in this one, once again, we still see our denominators are the same, so no adjustments needed. We can go ahead and perform this operation on the numerators. So we will have t minus 1. Now as I subtract, I am subtracting everything that was in that other denominator. So I'm going to put it in parentheses to emphasize that. Now this subtraction is going to distribute to both of those. So I would have t minus 1 minus t minus 1 all over t. All right, and now t minus t would be 0. Negative 1 minus 1 would be negative 2 over t. Okay. Now, the differences between this minus and that minus, where here we have a positive 1, on the right we have a negative 1. Here we have a negative n, over there we have a positive n. That's enough of a change to make it so that I cannot just add those numerators straight across. Something needs to happen. And so here's what I'm going to do to this first one, this first fraction. I'm going to go ahead and multiply the top and bottom by a negative 1. The reason for this is I need that 1 to be a negative, and I need that n to be a positive. So by multiplying the numerator and the denominator by a negative 1, we can then create this situation where we now have positive n and a minus 1. And I just moved them around because with addition, it doesn't matter what order you do it. Okay, and then we have a 1 plus n minus 1. In fact, I'm just going to write over here. That got multiplied by negative 1, and that got multiplied by negative 1. All right, so because I've now done that, we've got both these denominators are the same, so now we can just add our numerators. Okay, once again, we see kind of this weird difference where it almost looks the same, but not quite. So here's what I'm going to do for the bottom of that. So let's keep the top looking like that. If I factor out of the bottom a negative 1, that would make that a negative n, and then a positive 1. Okay, and so now those are the same. So we would have a 1 over a negative 1, which is just negative 1. Okay, all right. Now over here, we cannot use that same trick, and try and think about why that same trick is not going to work again to make these two the same. The problem is that while the negative 4 needs to change to a positive 4, the positive m is already a positive m on the other side. I can't change just one of the signs. So using a trick of like factoring out a negative or multiplying top and bottom by a -1, that's not going to help me here. That won't work. So instead, we need to make sure that the right-hand side gets a factor of an m plus 4, or the left-hand side gets a factor of m plus 4, and the right-hand side gets a factor of m minus 4. That way both will have the same denominator. So what I'm going to do is create this. I'm going to have an m plus 4, and that is multiplying by the 1 minus m minus 4. Then we got our minus the -2m plus 1 all over m plus 4. And on that side, we're going to multiply by the m minus 4 all over m minus 4. Now notice what's about to happen. Both of the denominators are going to have an m plus 4, m minus 4 in their denominator. The tricky part of this is we need to do this multiplication right here up top. So I'm going to quickly draw that over here. So I've got my m plus 4 and an m. Oh, that was supposed to be a 1 and a minus m. We'll go ahead and multiply those together. So an m, a 4, negative m squared, and negative 4m. All right, so on the top over here in the left, we're going to have negative m squared minus 3m plus 4 all over m plus 4, m minus 4. Minus sign. Now let's go ahead and figure out what's going to happen over here on the right. So we'll have negative 2m plus 1 and the m minus 4. So negative 2m squared, m, 8m, and negative 4. So negative 2m squared plus 9m minus 4. Okay, and we will have the same denominator, m plus 4, m minus 4. All right, now that we've done that, we need to remember to subtract everything through. So I'm just going to go ahead and do it this way. Subtracting a negative is just like adding it. So I'm going to change this to plus, and we're also going to just change all these signs. Minus, and then that would become a plus. So one of the ways you can subtract a whole expression is to just change all the signs on the inside. And I'm doing that right now so as to save myself time and space. So I'm going to have a negative m squared plus a 2m squared. So we'll just have m squared, negative 3m minus 9m, so we'll get negative 12m, positive 4 plus 4, so we get plus 8, all over m plus 4, m minus 4. And you can check that top to see if it can factor. I'd mostly be looking at what multiplies to give an 8, but could add to give a 12, and I don't really see anything, so that's going to be as simple as we can get it, since I don't see right now exactly how that would factor. All right, so we're going to go again. Notice we've got different denominators, so in order to make them the same, we're going to multiply this side by an 8 over an 8. And then this side will get multiplied by the y over y. That way both sides will show 8y. So we'll get 16 over 8y minus 3y squared over 8y. Now we can just subtract going across for the numerators. So 16 minus 3y squared all over 8y. Done. That's not going to factor anymore, so we're good. Next, we got a 3 and a 4x. So I'm going to go ahead and multiply this other side by a 4x over a 4x. So 4x over 3, so that we can create a common denominator with this other side, so 3 over 4x. That is going to be multiplied by a 3 over a 3. So then we'll get 16x squared all over 12x minus 9 over 12x all over, so that'll be 16x squared minus 9 all over 12x. Now that top we can actually factor. That would just be a difference of squares. So that would look like a 4x minus 3 and a 4x plus a 3 all over 12x, although doing that factoring doesn't really help me find anything to eliminate. It's always good to check, though, whenever you're doing this. Check. Sometimes problems can balloon and get bigger and bigger and bigger and more complicated. And part of the thing that was making it so challenging is if you failed to eliminate a part of a fraction that you could have eliminated earlier on. But nothing really there. So we can just go ahead and leave it just like that. All right, left-hand denominator has an a, right-hand denominator has a 2. They don't have anything in common, so what we're going to do is just multiply the left side by a 2 over a 2. And the right-hand side should get multiplied by a over a. So that on both sides of this, we can then get a 2a for the denominator. So up here, also recognize that's going to need to be distributive property. So 4a plus 2 all over 2a plus a squared plus 2a all over 2a. So combining that through, we'll get a squared plus 6a plus 2 all over 2a. I don't really see how we would factor the numerator, so we're just going to leave it like that. All right, final 3 problems were right there. And I'm hoping that at this point, one thing that is going through your brain is it's pretty much the same thing over and over and over. And yes, it is. Once you get the algorithm down, once you understand the basic process, the process just repeats. And then all that's left is to practice it enough that you get good and you can do it nice and fast. All right, so multiplied by the opposites denominators. So we're then going to get 3x, 3x all over ax. I'm just rearranging them to be in alphabetical order because that's the way I like it. And now that the denominators are the same, we can go ahead and add the numerators. So 3x plus 4a all over ax. And we're done. In this next one, we don't even see it as a fraction. So if that ever confuses you, just remember that anything is a fraction, just put a 1 under it. Now, in this case, all I'm going to need to do is multiply this other side by b. And then they will have the exact same denominators. So I will have a b over a b plus an a over a b, which is the same as b plus a all over b. All right. So in this next one, once again, we do not have like denominators. We've got 3 different factors at play this time. But in this case, it's not going to make much of a difference because none of those factors are the same from fraction to fraction. So we're going to continue with what we've been doing about just multiply the opposite side by the entire denominator. So we will multiply this side by m x minus 1 all over m x minus 1 times by the m over x plus 4 over m x minus 1. And then we will multiply that by x over x. All right, so on the top here, and I'm just going to multiply this out, we're going to have an m times an m, which would be an m squared, and then we'll multiply that m squared through that inside. So we'll have m squared x minus m squared all over. And now we've got this m, x minus 1 times x. Just going to put my 2 fractions right in front, and then the x minus 1. Plus, over here, we'll just have 4x and an mx times x minus 1. Sadly, it doesn't look like we've got much that is going to combine here. And so our simplified version is just going to look like this. All right, so there's your lesson on adding rational expressions. Good luck on your assignment.